Welcome to my kcse revision channel. Teacher James Marita, Kirigoli Boys High School. Kindly subscribe my channel. Click the notification bell such that you get notified once I upload a new video. Follow me in my Facebook page, Marita James, the Ocean of Chemistry. You can also follow me in TikTok, Marita James, the Ocean of Chemistry. Today we are looking at KCSE revision, chemistry, a very important part that we are expecting this year, and that is the solvay process. Solvay process is normally found in carbon and it is compound, the last topic in Form 2. So in these solvay processes, so the first thing, things that you are supposed to understand from these solvay processes, you have to understand the raw material, the main reaction, and also the uses of some raw materials, the uses of the byproduct. You want also to know the reason why this process, solvay process, is efficient or is more economical. So the first step in this solvay process, as I've said, you have to identify the raw materials. What are the raw material in this solvay process? So the raw material in this solvay process, one, we have a brine. Brine is sodium chloride. We have limestone. Limestone is calcium carbonate. We have coke. Coke in this case is carbon. Then we have ammonia. So the main raw material, we talk of brine, we talk of limestone, we talk of coke, then you talk of ammonia, a very important part. So if you will be required to identify or give the starting material in this solvay process, you can name that one. So we have in the first chamber, we have ammonia and then we have brine. Ammonia and brine are taken in the ammonia absorber. In this case here, ammonia will just mix with the brine to form what you call the ammonical brine. Ammonical brine, if you will be asked to give the meaning of the ammonical brine is just a mixture of ammonia and brine. Brine, in this case, it is sodium chloride. So that is the meaning of this ammonical brine. So the ammonical brine is now taken into the solvay tower. The solvay tower, another name for this tower is called the carbonator. So we have the carbonator or the solvay tower. So in this case, what we have now a mixture of this one. That is a mixture of ammonia and brine inside here. In this solvay tower or the carbonator, as you can see, it has the purpose. So we have the purpose. So sometimes you will be required to give the uses or the purpose of this purpose. Later we are going to mention that one. But now here, there are two types of reaction which normally takes place here. There is the reaction at the upper part of this solvay tower, and also we have the reaction at the lower part of the solvay tower. So we have at the upper part of the solvay tower, the tower at the upper part here, we have a reaction which can take place there, where you can talk of we have ammonia gas, we just combine with water and also combine with carbon dioxide to form ammonium hydrogen carbonate. So ammonium hydrogen carbonate is normally formed at the upper part of the solvay tower. So very, very important to understand that there is the reaction at the upper part and there is the reaction at the lower part. So the upper part, as I repeat, that we have ammonia, we have carbon dioxide and water. So when they combine, the three combine, that's ammonia, water and carbon dioxide, they form ammonium hydrogen carbonate at the top. At the upper part, at the lower part now here, we have the ammonium hydrogen carbonate from the top. It will now combine with sodium. Chloride here. So the sodium chloride will just combine with the ammonium hydrogen carbonate. It forms now a mixture of sodium hydrogen carbonate and sodium ammonium chloride. So that is a mixture. You can have a mixture that will come out here. So in this case now here, so we have a mixture of sodium hydrogen carbonate and in this case ammonium chloride. This mixture, they can be separated using two methods. One, you can use a filter. If you use a filtration method to separate a mixture of sodium hydrogen carbonate and ammonium chloride, you will obtain ammonium chloride as a filtrate and sodium hydrogen carbonate as a residue. You can also use another method of separating this one. You can use also what you call it the fractional crystallization. When using the fractional crystallization, what you need to understand that the sodium hydrogen carbonate is less soluble at lower temperatures. So if you use the fractional crystallization, you can also the mixture can also be separated because sodium hydrogen carbonate is less soluble at lower temperatures. So you use now the filter that separate that one. After separating now, we have this ammonium chloride as a filtrate is now taken into the ammonia generator. So that one is taken into ammonia generator. We are going to see the type of the reaction which is going to take place there. But before that, we have the sodium hydrogen carbonate. We obtain sodium hydrogen carbonate as a residue. The residue of this sodium hydrogen carbonate is taken in the roaster. In the roaster, the sodium hydrogen carbonate will decompose. It is heated at a very high temperature, a temperature which is at around 300 degrees. So in this case, it will decompose. It will decompose in the presence of heat. So we have the sodium carbonate, we have carbon dioxide and water. So that is the product we have. So at the roaster here, a residue of sodium hydrogen carbonate is being roasted, it is being burned. The sodium hydrogen carbonate now will decompose. It decomposes into sodium carbonate plus CO2 plus water. A very important point you need to understand. Now, from here, water and the carbon dioxide are recycled. So if you will be required to give some of them the product which are being recycled in this process, water, carbon dioxide, and ammonia are being recycled. So you can have the water and ammonia being recycled and taken part in the solvent or in the carbonate in that case. So in this reaction, the reaction at the carbonator is highly exothermic. So the reaction at the carbonator is highly exothermic. A lot of heat is being generated. So to avoid that one, water is meant to run around the carbonator or to circulate around the carbonator such that to cool the product as the reaction is high, exothermic. Now, from here, we have the ammonium chloride as a filtrate. This one now is taken into the ammonia generator. In the ammonia generator, in this case, what is happening here in the ammonia generator? In the ammonia generator here, we have the ammonia chloride plus the calcium hydroxide. Where is this calcium hydroxide? The calcium hydroxide is obtained in the kiln, in this kiln. In the kiln, we have a limestone. Limestone, in this case, when we are talking about the limestone is normally, this one here, it is a calcium carbonate. So limestone is calcium carbonate. So in the kiln here, there are two main reactions which takes place. One, you have the decomposition of calcium carbonate, whereby it will form the calcium oxide and the carbon dioxide gas. There are two raw materials we are introducing in this kiln. So we have the limestone and then we have the coke. The coke will also react with oxygen or it react with oxygen to form the carbon dioxide. So in the kiln, you are required to understand that there are two types of the reaction where we have the calcium carbonate. Calcium carbonate in the presence of heat, it can decompose to calcium oxide and CO2. Another main reaction in the kiln here, so we are introducing in the calcium carbonate and the coke. The coke can also react with oxygen to form the carbon dioxide. So the carbon dioxide is normally produced from here. Now, from the limestone, the decomposition of the limestone to form the calcium oxide and the CO2, The calcium oxide now will just drop down in the slacker here, where it will combine with water. So the calcium oxide from the kiln here will just combine with water in the slacker, and then it forms the calcium hydroxide. So the reaction which takes place in the slacker here, the product of the kiln, which is the calcium oxide, and the water will just mix here, and then the product we have from there, it is the calcium hydroxide. This calcium hydroxide, as you can see, it is taken in the ammonia generator. So this one is taken in the ammonia generator. And again, we have ammonium chloride is also taken in the ammonia generator. So there are two products which are taken in the ammonia generator. One, we have the ammonium chloride, and then we have the calcium hydroxide. So these two are now taken in the ammonia generator. Once they are taken in the ammonia generator, now what will happen? You realize that ammonium chloride will now combine with that calcium hydroxide to form the calcium chloride, ammonia gas, and water. So that is the main reaction that takes place in the ammonia generator. So in the ammonia generator, we have ammonium chloride, then we have the calcium hydroxide, then we have the calcium chloride plus ammonia plus water. A very, very important point to understand here, that we have from here we have a byproduct of calcium chloride. We have a byproduct of calcium chloride. But water and ammonia are being recycled back. So you can see now water, ammonia is being generated. So ammonia and water are being recycled back. And then now we have them in the ammonia. We have them in the ammonia observer. So that is what we have there. So from there you understand that we have, as I've said, that we have the calcium hydroxide here. This calcium oxide will just enter here, and then from this side we have the ammonia. The two now will just combine to have they will just combine to have ammonia, gas, calcium chloride, and water. Remember, ammonia gas and water are being recycled. That is how a summary of how the reaction takes place in this solvay tower. So a summary of that one, very fast. We have the ammonia observer, and then we have where we have the brine and ammonia. Then we have the ammonium brine. This one will be taken into the solvay tower or the carbonator, where there are two main reactions which takes place there. That two main reaction now will combine. Then we have an overall reaction whereby we have sodium chloride plus ammonia gas plus water plus CO2. Then we have a mixture of ammonium chloride, and then we have sodium hydrogen carbonate. Two methods can be used to separate the mixture. You can use either the fractional crystallization. You can use either the fractional crystallization, or you can use the filtration to obtain the filtrate of ammonium chloride and a ratio of sodium hydrogen carbonate. Sodium hydrogen carbonate is taken in the roaster, whereby they will decompose at a very high temperature. Then it produces the sodium carbonate plus CO2 plus water. Water and CO2 are being recycled. And again, I have said that in the solvay tower, the reaction is highly exothermic, so water is meant to circulate around the carbonator or that solvay tower, such that to cool the product. And then we have now ammonia and the calcium hydroxide from the decomposition of this limestone. It is taken in the ammonia generator. In the ammonia generator now, the ammonia gas is being generated. Now, what are some of the other important things that you are supposed to understand from this the solvay tower? From this solvay process. In the solvay process one, we have the ammonium brine. Ammonium brine, if you will be required to give the meaning of the ammonium brine, you just say that this is a mixture of ammonia and brine. So you can also be required to give this process is said to be more efficient. Give a reason why the process is said to be more efficient. The process is said to be more efficient because most of the product are being recycled. Water is recycled, ammonia is recycled, the CO2 is also recycled. So most of the product are also recycled. And again, we have the purpose. We have the purpose in this solvay tower. Sometimes you will be required to give the function or the purpose of this purpose. The purpose now in this case here, it allows liquids to trickle down slowly and then to allow more time for proper mixing of gases. So that is one function of this bubble. Then we have the bubbles also, it increases the surface area for the gases to dissolve in liquids. Again, you will be required to give maybe the use of this byproduct of calcium chloride. So calcium chloride in this case, as you know that the calcium chloride is used as a drying agent. So when you are required to give the uses of this calcium chloride, you just say it is used as a drying agent for gases which does not react with it. And also this calcium chloride is also used in the extraction of sodium. Remember in Form 4 during the extraction of metal, one of the metal in Form 4 we have extraction of sodium. Extraction of sodium, it requires a very high temperature. So to lower that melting point, the calcium chloride is normally added to lower the melting point of that sodium metal. So in that case now, we have calcium chloride in this case. There are normally two main uses. It is used as a drying agent. It can also be used in the extraction of sodium. We have also the use of sodium carbonate. Where is sodium carbonate? Sodium carbonate is normally a product of the roaster. It is produced during the decomposition of sodium hydrogen carbonate. So what happens there, the sodium hydrogen carbonate here, it is used in the manufacture of glass. So that is one use of the sodium hydrogen carbonate. It can be used in the manufacture of glass. You can also say that sodium hydrogen carbonate is also used in the paper industry. It can also be used in softening hard water. We have the sodium hydrogen carbonate. The sodium hydrogen carbonate, this sodium hydrogen carbonate is obtained where? The sodium hydrogen carbonate is normally obtained from the solvay tower or in the carbonator. What is the use? If you will be required or you will be asked to give one use of sodium hydrogen carbonate, you just say that sodium hydrogen carbonate is used in the manufacture of baking powder. It can also be used in the manufacture of dilated drinks. We have also that this plant, that is the solvay plant, the solvay process, should be located near a river, should be located near water bodies. Why? So give reasons why it is located near water or it's located near a river. So if you are required to answer such a question, you just say water is a raw material. Water is also required to cool some. Water is also required as a coolant. Water is needed as a coolant. Now, what is the advantage of this recycling? We have said that we have some product here which are being recycled. We have ammonia which is being recycled. We have the ammonia is being recycled. We have water is also recycled. And then we have the carbon dioxide which is also being recycled. What is now the advantages of this recycling? Recycling, the advantages of this one, it minimizes the production, and also you can also say that this one, it minimizes the pollution. It minimizes the pollution. Now, you can also be required to give the cost incurred in running the plant. Cost incurred in running the plant, there are normally two. That is the power cost, or you can also talk of the maintenance costs. So this is a summary of the solvay process, and remember we are expecting a question from carbon and this compound, and this is the part we are highly expecting this year. Don't forget to subscribe, watch and share.